Welcome everyone. Our lesson today is about continue the lesson of proportional, okay? And this lesson is talking about constant proportionality, okay? Actually, as we studied before, as an example, 1 over 2, this ratio equals 2 over 4 equals 3 over 6. This all are the same ratio. They are proportional. Why? 1 over 2 is still 1 over 2. No simplify. If we simplify this, divided 2 equal 1 divided 2 equal 2. It's 1 over 2 equals the same. Divide 3 equal 1, divide 3 equal 2. So I have 1 over 2. Same number. So it's constant. Constant means fixed number, that it's not changing. So I can call the relation between ratios, if it's proportional, so it must have constant proportionality, okay? So if we take an example here for this example, a sponge, actually, as you know, a sponge is an animal, lives in the water, okay? He takes food by this way. He eat food, his food by this way. I told you now, okay? A sponge is an example of filter feeder. It takes in food by filtering water through its body. The sponge maintains a constant flow of water through its body. So it takes a fixed number, okay, constant number of water. Okay. What is an equation that represents the proportional relationship between the time and the amount of water filtered? Okay, how? Now, this sponge will need to feed itself. So it filters the water. So each 8 liter of water, it takes 8 liter of water takes 10 hours to filter it, okay? And if they are 12, it takes 15 hours. Okay, I can represent this relation as the following example of this table. So I can find that in each 8 hours, it feeds itself by 8 liters of water. Okay, so 8 divided 10 equals, I can simplify, divided 2. I can write it in decimal way like this way, or I can simplify, so it's divided 2 equal 4, divided 2 equal 5, so I can write it as 4 over 5, or 0.8, it's okay. Okay. Also, when we calculate it for 12 liter, we found it filtered 12 liter in 15 hours. So 12 over 15 divided by 4 equal, divided by 3 equal 4, divided by 3 equal 5. So it's also 4 over 5. Same ratio, which is equal 0.8. Same, so they are proportional. Because they are proportional, they have a fixed number or a constant number. We call this number K. We will call this number K, as you see here, okay? So I can call it K, and K here is equal 0.8. So I can represent this relation as the fraction y over x. Y represents the liters, and x represents the hours, okay? Equal a fixed number called K. By cross multiplication, we found that y equals kx, and I can write it y in the left hand side to be in this form, y equal kx. So if the relation between y and x is proportional, I can write it as y equal constant number, which is denoted by k, multiply x. In this case, k here equal 0.8, so I can write it as y equal 0.8x. So if first of all I have to check if the numbers are proportional or not. If he said to me it's proportional, so I must find the constant number, which is k, and write the relation y equal kx, like this way. Okay? Okay. Let's take another example. Okay, this example is talking about pylon A is raised 5 feet above the ground. Okay. Pylon P is raised at ground level, at the ground. So I can describe it like this way. I have this ground level. I have one pylon like this on the ground, and another one pylon is like this above the ground, which is 5 feet. And this is 0 feet, okay, on the ground. Okay? Both pylons raise at the constant rate. Okay, they raise at the constant rate. Okay, let's see this rate. Which situation of this rate can you represent using an equation of the form y equal kx? Actually, I will not use y equal kx except if I have proportional relation, because y equal kx represent a proportional relation. Okay, let's see if these numbers are proportional or no. If I make a height, so I will take the ratio of height to time. Height to time, so it's here 9/1, which is equal 9. Second one, 13/2, which is equal 13/2 equals 13/2 equals 6.5. It's not the same, so they are not proportional. So the first relation is not proportional. Let's check the other one. So the first number, it's 4/1 equal 4. Second one, it's 8/2 equal 4. Yes. Third one, it's 12/3, which is equal 4 too. So the same number, fixed number, so they are proportional. And its fixed number is, which is k, equal 4. So I can write it in the form of y equal k x, and instead of k I can write y equal 4x. So the constant proportional here is 4. Okay, so I can write it in the equation of y equal 4x. Okay? Okay, let's move to another example. Okay, in this example, he asks me determine whether each equation represents a proportional relationship. If it does, identify the constant of proportionality. Actually, as we know before, to know if the relation is proportional relation, I can write it in this way: y equal something multiply x. This something is constant, we call it k. So if I can find constant number here, multiply x, y equal number multiply x, so it will be proportional. Okay, let's check the first one. First one, actually, y equal constant multiply x, but minus 2. This equation is not included minus or plus. No, not included plus or minus. So I can't say this is proportional. This is not proportional actually, because it's not in the form y equal kx only, not proportional. Okay. Okay. What about the next one? Next example is talk about y equal 1000 x. It means 1000 multiply x. Is this in the form y equal kx? Yes, that's right. K here equal 1000. So the constant of the proportional here is 1000. So this is proportional relation. Okay. Okay. What about the last one? Y equals something multiply x plus 1. But I don't have plus or minus. As I told you, I must have number multiply x only without plus or minus, so it's not proportional. Okay, I'll give you an example. Okay, if I give you question D, y equal x, it's a proportional relation or not? Okay, actually I can write y equal something multiply x. What multiply x equal x? Actually it's 1. So 1 multiply x equal x. So yes, it's proportional. And its constant k equal here what? Equal 1. That's right. Okay, that's it for today. An easy lesson. Wish you all understand it. See you next time. Bye.